Okay, good day. For today's video presentation, we will be discussing integrals of trigonometric functions. So, in finding the integral of integral involving trigonometric functions, so there are different ways on how to do it. Okay, but we need to recall. Okay, so the different differentiation techniques for trigo functions, as well as some trigo identities, so which are very useful so in finding the given integral involving trigonometric functions. Okay, so the integral or the method of integration that we will be using, which involves trigo functions, so comprises of different techniques. So we can even use the power rule. Okay, so as long as once we derive a certain value of u, so we'll be able to find the differential or the derivative involved on the integrand. We can use exponential functions that involves trigo functions. We can use as well the inverse trigo, or sorry, the logarithm in evaluating functions or in finding the integral of functions involving trigo functions. In short, so any method will be applicable. Okay, so as long as or it depends on the format of the integrand. Okay, so we just need to identify so whether the integral is just simply the integral using the formula for trigo functions, so whether we need some or we need to use some trigo identities to simplify the function, so for us to find the integral, okay, to find a format so which is best suited in finding the integral of trigo functions. Or sometimes, so as I've mentioned, so we can even use the technique for exponential function, for logarithmic functions, or even for uh, power rule. Okay, so let's try to recall. Okay, so some of the trigo identities, so particularly the 6 basic trigo identities, so which is very useful. Again, so in finding the integral of trigo functions. So the first set would be the sine. Okay, so sine is just the inverse of cosecant, and then cosine would be the inverse of secant. Then of course, so for tangent, so tangent is actually sine x over cosine x, and at the same time it's the reciprocal for cotangent. So cotangent is so this should be tangent. Okay, so 1 over tangent x, or it could be cosine x over sine x. And then we have the second x, so which is equal to 1 over cosine x, and then cosecant is 1 over sine x. So aside from the 6 basic trigo functions, so we have as well the trigo function using the Pythagorean theorem. Okay? So the Pythagorean identities are the following. So wherein we have sine squared plus cosine squared is equals to 1. And then we have as well the double angle. Okay, so for sine, so sine 2x is the same as 2 sine x cosine x. So if it is cosine 2x, so we could have the cosine squared x minus sine squared x. But then if we have a cosine squared x, because in itself cosine squared x cannot be integrated, so most of the time, so we find its equivalent identity, and the useful identity that we will be using is the 1 plus cosine 2x all over 2. So this is the same as with sine squared x. So the only difference is whenever it is sine, it's negative. Okay, it's minus, and then for cosine squared, it's plus. Then we have another trigo identity, or the Pythagorean identity for tangent. So tangent is a combination of secant. So 1 plus tangent squared is equals to secant squared. And similarly, so we have the 1 plus cotangent squared is equals to cosecant squared x. So at least we should know these Pythagorean identities, so plus the at least the two double angle identity for sine and cosine will be able to solve. Okay, so most of the integrals, so involving trigo functions. And then we have to recall as well the rules of differentiation. Okay, so this should be very clear to us because whenever we are integrating, especially if we're using power rule, we're using logarithmic function or even exponential function, so we need to have a clear grasp about the differentiation formula. Okay, so in such a way that the derivative of sine is cosine, and then the derivative of cosine is negative. Sorry, so this should be a negative sine x. Then the derivative of tangent is secant squared. Derivative of cotangent x is negative cosecant squared x. So derivative of secant is secant and tangent, and then the derivative of cosecant is negative cosecant and cotangent. Okay? So take note of the correction here. So cosine is negative sine x. It's because the reverse process, okay, of differentiation would be the integration. So in this case, what we have, okay, is the following. Okay, so we could have the integral of cosine, the integral of sine, integral of secant squared, integral of cosecant, integral of secant and tangent, and integral of cosecant and cotangent will be all of these. Okay, so that's why on the next set of rules, okay, so in finding the integral of trigo functions, so this is what we have here. Okay, so the integral of sine x is negative cosine x, and then integral of cosine x is sine x plus c. And as you can see here, so it's not right away mentioned or specified. So what are the integral of secant, cosecant, cotangent, and tangent? But rather, so we have special cases wherein secant squared, so its integral is tangent x because the derivative of tangent x is secant squared x. So similarly, so we have the integral of cosecant squared x, so which is negative cotangent x. Okay, so these are special cases that sometimes, so we need to write away c, okay, on the given integrand. So there are times that, especially if we are already thinking of so many things about what to use, when to use a specific formula, so sometimes it's already there. Okay, so on the given integrand, it's already given that we have a secant and tangent x, and then we're still thinking of complicated things on how to find its integral, wherein there is a direct integral for the product of secant x and tangent x, so which is secant x plus c. And for cosecant and cotangent, it's negative cosecant x plus c. So the thing that we need to recall here is that, so as long as the answer, okay, so starts with letter C, okay, so this is negative cosine, this is negative cotangent, and this is negative cosecant. Okay, so as long as it starts with letter C, then the sign will be negative. Okay, so if you want to recall, so when will it be positive or when will it be negative? Okay, so sine and cosine is the basic. Okay, so are the two basic trigo functions, so which has a direct integral, the negative cosine x and the positive sine x. But we have four special cases here: the secant squared, cosecant squared, and secant tangent and cosecant cotangent, because those are the reverse formula. Okay, so for the trigo functions which has direct integral. But then we have additional four integrals. Okay, so for tangent and cotangent as well as for secant and cosecant. Okay, so the tangent x, so tangent x is actually taken so from it's actually taken using the natural logarithm, because remember, so let's say we have the tangent x dx, so this is the same as, so using the trigo identity, so this is sine x over cosine x dx. And then if I'm going to let u to be cosine x, and then du will become negative sine x dx. So which is, so once I transform this one, so this is the same as negative du, then all over cosine x, so which is u. So negative du over u, that's the same as negative ln u, wherein u is cosine x. So that is why we have here the negative ln cosine x plus c. But then, so we can apply the rules of logarithm. So ln of cosine x, and then raise it to negative 1 plus c. And then 1 over cosine x, that is the same as secant x. So that is why we have the ln secant x for the tangent. But then for cotangent, cotangent is cosine over sine. So derivative of sine is cosine. So therefore, the direct integral of cotangent x is ln sine x. So we don't need to show on our solution, so how are these derived? Because these are acceptable formula that once we have the integral of cotangent x, so right away that would be a ln sine x. Okay, so for the integral of secant x, so secant x so was derived, okay, so by multiplying, okay, so the secant x plus tangent x all over secant x plus tangent x dx. Okay, so this is a special case. So it's because, so once we have done that one, so we just multiplied it by 1. So since that is secant x plus tangent x all over secant x plus tangent x, that is equal to 1. So we just multiply that one, so for us to get the direct integral of secant x. So from here, so we can let u, so to be the denominator, which is secant x plus tangent x. And then our derivative then, so would be the integral. Okay, so by the way, this is multiplied here. Or the derivative of secant x is secant x tangent x. And then derivative of tangent x is secant squared x. So once we factor out secant x, so that would give us a tangent x plus secant x. So which is exactly the numerator. So that's our, so this one would become, so this is du over u. Or that's just simply ln u. And now, so we have the ln of simply secant x plus tangent x. Okay, so that is how the integral for secant, okay, so was derived. So similarly, so this is the same process for cosecant, it's just negative. And then if we want to remove the negative sign, so it is acceptable as well that the integral of cosecant is ln cosecant x minus cotangent x. Okay, so all of the other 4 basic trigo functions, so that is tangent, cotangent, secant, and cosecant, so has a direct integral. So using the natural logarithm. Okay, so those are acceptable formula. Okay, so we don't need to do just what I did. You just simply answer or provide the answer right away. Okay, so we have to remember the 10 at least. Okay, so 10 trigonometric integrals. Okay, so the 6 basic trigo function, and then the 4 cases, so which are the secant squared and cosecant squared, as well as the secant tangent and cosecant cotangent. Okay, so there are 10 integral formulas or integrals for trigonometric functions. So in cases, okay, so we can only use the following formula as long as the integrand resembles any of the 10. Okay, so if we are provided a certain integral, so which is not exactly the same as this 10, then that's the time that we need to use identities. Like for example, so we are given sine squared x dx. So there's no such thing as sine squared x for a direct integral. Okay, so we don't have formula for this one right away. So in those cases, so we can use some trigo identities. So in this case, I can change this one into 1 minus cosine 2x all over 2. dx. So this one has a direct integral because cosine 2x so can be or we can find its integral so using the formula for cosine x, and then 1/2, so that would be algebraic. So in cases when the integrand does not resemble any of the 10 trigonometric integrals, so that's the time that we go back to the following. So we need to recall all the trigo identities so for us to transform it into a format so which is integrable. Okay, so let's have our first example. So one is very direct. Okay, so I'm going to write the formula that I can use. So this one, so this is direct. We have the formula for cosine u du. Okay, so which is the same as sine u plus c. So we just need to transform this one into that format. So if that is the case, if this is the formula that we will be using as cosine u du, so for the integral of cosine 3x dx, so it would appear that we have to identify which is u. Okay, so whether the u is just the angle of the cosine or whether the u will be the entire cosine 3x. So in this case, our u, so since it falls under the 10 trigo integrals, then right away, so we can let u, okay, so we're going to let u so to be equal to 3x. And then du, so will be, so derivative of 3x will be 3 dx. So now, so for simplicity, so since our du here, so we have our main function, so which is cosine 3x, and then our differential here is just dx, so we don't have any numerical coefficient. So therefore, so we need to find, okay, so the neutralizing factor. So the one in excess is 1/3. Okay, so we have now the neutralizing factor which is 1/3. So therefore, so in answering this, so that would just be, so we write 1/3. Okay, and then so what's the integral of cosine 3x? So this one, so which is sine u. Our u is 3x, so that is sine 3x plus c. So that is how we find the answer. Okay. So 1/3 sine 3x plus c. So we need to neutralize the numerical coefficient, the 3, okay, so which is in excess, so that's why we are multiplying it by 1/3. For number 2, so in this case, so we have a product of secant 2x and tangent 2x. So remember that in integration, so we can only integrate right away if it is separated by plus and minus. But then if it is a product between this one, in this case secant 2x and tangent 2x, it's product. It's not possible to find the integral of secant 2x and then find the integral of tangent 2x and then we multiply the answer. Okay, so there's no such property in integration. Okay, so we cannot distribute. Okay, so this is not the same as 5, the integral of secant 2x, and then multiply it with the integral of tangent 2x. Okay, so there's no such thing. Okay, so there's no such thing. So it's a product. Okay, so in that case, usually if there is a product, so we use identities. But then it just so happen in this particular example, so we don't even need to use that. It's because secant and tangent is a special case. Okay, so we have a direct integral for secant x and tangent x. So remember, the secant u tangent u du is the same as secant u plus c. Okay, so this is one formula among the 10 trigo formulas. So secant u tangent u, so its integral is equal to secant u plus c. So in this case, so I could just write this one, so I can move out 5. So since that is a product, so 5 secant 2x tangent 2x dx. So in this case, so our u, so would be the u here, so which is 2x. And then du will be 2 dx. So we are in excess of 2. So therefore, we have a neutralizing factor of 1/2. And thus, so we have the neutralizing factor of, or we start with 5, and then the neutralizing factor of 1/2. And then secant 2x and tangent 2x, so it's this formula, so which is secant u plus c. So that means that the secant, our u is 2x and then plus c. So thus we have 5 over 2, so secant 2x plus c. So for our final answer. Okay. I cannot make it. Okay, anyway. So we have 5 over 2 secant 2x plus c. So for the answer of that one. Okay, so next. So we have the cosine x plus sine x raised to 2. Okay. So although this is plus, as I mentioned, so that would be possible to integrate cosine and sine x. But the thing here is it has a square there. Okay. So there's no direct integral for this one. Okay. So there's no integral which has a certain power, so which is raised to 2. Okay. So in cases like that, so again, if there's an operation involved, so try to perform the operation. In this case, so we might need to expand. Okay, so it's a binomial expansion of sine and cosine. Okay, so in that case, so I need to expand this first. So that would be the this will be, so cosine squared or cosine x, then square it. So that would become cosine squared x. Then so multiply it. So 2 times cosine times sine. So that would be plus 2 sine x cosine x. And lastly, so we have sine x raised to 2, that would be plus sine squared x dx. So now, again, so we don't have direct integral for cosine squared as well as for sine squared. For sine x cosine x, so we can do this one by power rule. But then, as you can see here, so there's something that is there we can simplify. Okay, so we can even simplify the given integrand. So remember that cosine squared x plus sine squared x is a Pythagorean identity, so which is equal to 1. And at the same time, so 2 sine x and cosine x is the same as sine 2x. So therefore, so I can transform the cosine squared x plus sine squared x, so to be equal to 1, and then the 2 sine x cosine x, so to be equal to plus sine 2x dx. So from here, so I can make u to be 2x, so du to be 2 dx, and my neutralizing factor for sine 2x will be 1/2. Okay, and again, remember that the integral of sine u du is the same as negative cosine u plus c. So we can now find the integral of this. So integral of 1 times dx is just simply x. And then for sine 2x, so we have a neutralizing factor of 1/2. And then the integral of sine is negative cosine. Okay, so which is negative cosine of 2x and then plus c. Or just simply x minus 1/2 cosine 2x plus c. And that will be our final answer. So identities were used first. So or we need to expand the given integrand first. And then afterwards, so once we can see some identities there, so we simplified it. So in this case, we used the Pythagorean identity for sine and cosine, as well as the double angle identity for sine. So doing that, so we have transformed the integrand to its equivalent integrand of 1 plus sine 2x. So 1 can be integrated as just simply x, and then sine 2x the integral of that is negative cosine 2x. Since we have 2x, so our neutralizing factor will be 1/2. So thus we have x minus 1/2 cosine 2x plus c. Okay? So for number 3, it's not a direct integral of trigo functions. Okay? So an expansion was done first, and then afterwards, so we simplify it until we can integrate it right away. So number 4 is the same thing. Okay, so for number 4, we will be expanding it. So similar on example number 3. So 3 square, so will be 9. And then, so binomial expansion, 2 times 3 times tangent x. So that would be, so 2 times 3 is 6 tangent x. And then tangent x squared, so that would become plus tangent squared x dx. So now, so we just have a simple integrand, so we don't have the power of 2 anymore. But let's try to see each given term. So for the first term, so which is 9, so we can integrate that right away. So 6 tangent, so it's tangent is one of the 10 basic integral. So we have an integral for that one. Okay. So what we don't have is the tangent squared. Okay, so tangent squared, so we don't have this one among the 10 integrals. But we have an identity. Okay, so as long as it involves tangent, so we can use this identity that 1 plus tangent squared x is equals to secant squared x. And thus, tangent squared x is equals to secant squared x minus 1. So once we transform this one, it will become 9 plus 6 tangent x. And then the tangent squared, so will become secant squared x minus 1 dx. And 9 minus 1 is 8 plus 6 tangent x plus secant squared x dx. So remember that the integral of tangent x is the same as sine over cosine. So ln of secant x. So while the integral of, we have an integral this time of secant squared. Okay, so that is a special integral. So which is the tangent x. So integral of secant squared is just simply the tangent x. So thus we have the integral of 8 dx, that would be 8x. Then plus 6 tangent x is ln of secant x. And then plus tangent x plus c. Okay. So 8 is 8x. So tangent x is 6 ln x. So plus tangent x plus c. So this one is okay, but then if let's say it's a multiple choice exam, so this one can be rewritten as ln of secant to the 6x, okay, plus tangent x plus c. So applying properties of logarithm, so we can move up the 6 as the power of secant x, okay, or just simply ln of secant to the 6 secant x raised to the power of 6. So plus tangent x. So any of the two, so will do. So we have that answer. So 8x plus 6 ln of secant x plus tangent x plus c. And that would be the final answer for example number 4. Okay. For example number 5, again, so the operation involved here is a division. Okay, so it's a rational integrand. So sine 3x all over 4 plus cosine 3x. Okay, so in similar way, we cannot just integrate sine 3x and then integrate the 4 plus cosine 3x. That's the answer. So this is the same as product rule. Okay, so we cannot distribute the integral operation to the numerator and the denominator. But rather, okay, so if you can combine the sine and cosine, the better. But we have to think of the previous principles. Okay? So for rational functions, if logarithm, so we'll do. Okay, so we tried the logarithm because in this case, if we're going to let u so to be equal to 4 plus cosine 3x, so we can derive this one as derivative of 4 is 0, derivative of cosine 3x, so that will be negative, okay, sine 3x, and then derivative of 3x is 3 dx. So sine 3x 3 dx. So this time, so this is sine 3x, so this is sine 3x dx. So we can now have a neutralizing factor, so which is negative 1/3. Okay, so we are in excess of negative 1/3. And as you can see here, so this one serves as our du. And then the one at the denominator serves as our u. So therefore, the integral of du over u is just simply ln u. Or in this case, so we start with the neutralizing factor of negative 1/3, and then we'll have ln of 4 plus cosine 3x. So we have negative 1/3, so ln of 4 plus cosine 3x, plus of course c. So we could have this one, or we can move up. So we can write this as well as ln of 4 plus cosine 3x, and then raise it to negative 1/3. Okay? Or we can make this one as 1 over, okay? So 1 over 4 plus cosine 3x raised to positive 1/3. So that will be fine. We could have it as well as 1 over the cube root of 4 plus cosine 3x plus c. Okay. But then this will do already. So negative 1/3, so ln of 4 plus cosine 3x. Okay, so for number 6, so this is a bit complicated again. So we have cosecant squared x, and then the square root of 5 minus cotangent x. But then if we're going to use some identities here, so it will be difficult to simplify this one because of the radical sign there. But as long as you can see whenever you see cosine and then you see sine, okay, so most probably, so it's either we can use power rule, logarithm, or exponential function. So the pair of tangent so will be secant, and then the pair of cotangent is cosecant. Okay, so if those two appears on the integrand, so most probably it could be it could be a logarithm, or it could be a power rule. Okay, so in this case, so since this is not the ratio, so I'm going to exclude logarithm already. Okay, so because logarithm involves rational integrand. But for this example, it has a radical. So if I'm going to rewrite this, so this would be the same as 5 minus cotangent x, then raise it to 1/2, and then I multiply it with cosecant squared x dx. Because I'm planning to let u so to be equal to 5 minus cotangent x, and then my du then so will be derivative of 5 is 0, so negative, then the derivative of cotangent will be negative cosecant squared x dx. So du then makes it positive cosecant squared x dx. So which is exactly as this. Okay, so this is u raised to 1/2, and then multiply it with du. So therefore, we're just going to use the power rule. So you can substitute if you want. But I already know it, that this is u raised to 1/2 du. So what I'm going to do would just be I'm going to write the u, so which is 5 minus cotangent x, then 1 half plus 1, so that will be 3 over 2 all over 3 all over 2, and that would be plus c. So finally, that will become 2/3 of 5 minus cotangent x raised to 3 all over 2 plus c. So using some power rule, okay? So that is the usual clue there, okay? So sometimes we just need to be familiar with the integrand, okay? So if it is a sine and a cosine, okay, so probably that's a power rule. If it involves a ratio, logarithm. So similar with this one, if it is a pair of tangent and secant or a cotangent and a cosecant, that's already a clue. Okay, so again, look at the pair here. So we have a pair of a cosine and a sine, and then it involves an exponential function. So most probably, okay, so again, so this is an exponential function. So actually, the Euler function. Again, so Euler function is a special case of an exponential function. Okay. So cosine x e raised to 4 plus 4 sine x dx. So this one, I can rewrite this as simply the integral of e raised to 4 plus 4 sine x, then multiply it with cosine x dx. So it would appear that it suggests that our u will be 4 plus 4 sine x. So our du will be, derivative of 4 will be 0, and then 4. So I'll have 4, 4. Then derivative of sine will be positive cosine x dx. So we have the cosine x dx there. So we are in excess of 4. So therefore, we have a neutralizing factor of 1/4. So what would happen then? So this one would be transformed as EU. And then that one would be transformed as our DU. Then remember that the integral of EU DU is EU plus C. Okay, so integral of EU DU is just simply EU plus C. So thus we write this one. So we start with the neutralizing factor of 1/4. So our EU is 4 plus 4 sine x, and then plus C. So we have number 7. So as you can see here, so number 7 is a trigo function involving the Euler function. Then we have the power rule for trigo function. Number 5 is a logarithmic rule, so for trigo function. Okay, so meaning it doesn't mean that we have a trigo function, the solution would be the integral of trigo function. Okay, so but rather, so we can combine that one using the different formula that we had before. So how to identify? So we just need to solve more problems. Okay, so the more problems that you solve, the more that you will be acquainted on what specific method are you going to use in finding the integral of that function. Okay. So for this one, so we have sine 3x and then cosine of cosine 3x dx. It would appear, okay, so this is a direct integral. Because remember that the integral of cosine u du is the same as sine u plus c. In this case, so I can change this one into this one. So cosine of cosine 3x. So 3x, cosine 3x here is the angle of cosine. So which is multiplied with sine 3x dx. So this is the same as this. So cosine u du. So this would serve as our cosine u, and this serves as our du. Is that the correct one? So if this is cosine u, therefore our u is cosine 3x. So our du will be derivative of cosine, so that would be negative sine 3x, and then derivative of 3x is 3 dx. So which is the same as this. But then in excess of negative 3, so that is why we have a neutralizing factor of negative 1/3. So sine 3x, and then the neutralizing factor is negative 1/3. So therefore, I can now use this formula. So it's just simply the neutralizing factor of negative 1/3, and then the sine u plus c. So sine, our u is cosine 3x, and plus c. So negative 1/3 sine of cosine 3x plus c. So in this case, our u is, or the angle is a trigo function. So in that case, that is cosine 3x. So sine 3x, cosine of cosine 3x dx. Okay, so that's the 8th example. Okay, so how about this? So we have cosine x, ln of sine x, sine x. Okay. So this is a ratio. So we can make this one as possible as logarithm. So it would be possible to use power rule. Anyway, so if it's logarithm, our u is at the denominator. But in this case, it would appear that our u is at the numerator, which is the ln of sine x. If I'm going to let u, so to be the one that I can derive, so that would resemble cosine x and sine x here, so would be ln of sine x. So once we derive this, derivative for ln would be du over u. So derivative of sine x is cosine x dx, then divide it with sine x. Okay, so remember, du over u, derivative of sine x is cosine x, and then over x, so which is sine x. So cosine x dx. And as you can see here, so to clearly see it, so this one, I can rewrite this as ln of sine x, and then multiply it with cosine x over sine x dx. So this one would serve as our u, so which is ln sine x, and the whole of this is du. So in short, so that would just be u squared all over 2 for power rule. Or that would be our u is ln of squared sine x divided with 2 plus c. So we just simply use power rule. Okay, so u du is u squared all over 2. Our u is ln sine x. Okay, so u squared is ln squared sine x all over 2. Okay. Power rule again. Okay, so for number 10, so although we have a ratio here, so definitely, so once we derive cosine x, so it will become sine x. So we cannot get the numerator. So logarithm is not possible. Power rule is not possible as well. So both of them are cosine. The two doesn't have even the same angle. So one is 2x, the other is just x. So we cannot use power rule or logarithm here. So we cannot see exponential function. So therefore, or we cannot see the Euler function. So therefore, we cannot use that one as well. So therefore, the only way on how to do this one is to simplify it. Okay, so using some identities. So for cosine 2x, we have a direct identity of cosine 2x, so which involves cosine. Okay, so you just need to recall that cosine 2x is the same as, by the way, so we have, I think I have not written that. So this is the same as cosine squared x minus sine squared x. But then our denominator is just purely cosine. So I want to make my numerator cosine as well. So that is why I'm going to change sine squared, so to be the same as 1 minus cosine squared x. So that makes it, so negative and negative cosine squared, or cosine squared x, so minus 1, that would be plus cosine squared x. So that makes it cosine squared x, or 2 cosine squared x minus 1. Okay, so this is actually a direct integral of, or direct identity for cosine 2x. Aside from this, so we have another identity. So double angle involving cosine only. And that is what I want to do with this one. I'm going to change the cosine 2x into simply, so 2 cosine squared x minus 1 all over cosine x dx. And now I can separate the two. So this is the same as 2 cosine squared x all over cosine x. The other one is minus 1 all over cosine x dx. And I have 2 cosine squared over cosine. So that's the same as 2 cosine x. Then identity for 1 over cosine. So that will be secant x dx. So 2 cosine is 2 cosine x. 1 over cosine is secant. And again, so we have direct integral for cosine as well as for secant. Okay, so 2 cosine, so the integral of cosine will be positive sign. So we'll have 2 sine x. And then for secant, so we have minus ln of secant x plus tangent x plus c. So 2 sine x minus ln of secant x plus tangent x plus c. That is our example number 10. Okay, so in this case we use identities. I think we have 2 more. Example number 11. So we have sine x all over 1 plus sine x. In cases like this, so we have sine x over 1 plus sine x. So its ratio, so is logarithm possible. So if this is logarithm, my u will be 1 plus sine x. Once I derive that, it is cosine x. Our numerator is sine x, so therefore we cannot use that. So power rule cannot be used as well. So the only way to do this one is to do some identity. So how do we do that? So we find the conjugate, okay, of this. So as to transform the denominator, the problem here is the denominator. It's 1 plus sine x. So I want to transform this one into a single function. So what I'm going to do is I'm going to multiply the conjugate. So 1 plus sine x. So I'm going to multiply it with 1 minus sine x all over 1 minus sine x. So because 1 over sine x over 1 minus sine x is just 1. So the conjugate of 1 plus sine x. So doing that, so that would give us, so sine x, so multiplied it with 1 minus sine x. And then this is a sum and difference. So therefore, so that this would be a difference of 2 squares. So 1 times 1 is 1, and then minus sine squared x dx. Then what can we do with this one? So I can distribute. So sine x times 1 will be sine x. So distribute it here. The next is there. So minus sine squared x all over 1 minus sine squared is the same as cosine squared x, right? So it's a Pythagorean identity, dx. Then afterwards, so I can separate the two. So this one would become sine x over cosine squared x, then minus sine squared x all over cosine squared x dx. So I'm going to add the new page. And then, since sine and cosine are just, or those are the pair, okay, pair of trigo function, so we can use the power rule here. So what I'm trying to do here will become, I'm going to change this one as cosine x raised to negative 2, then multiplied it with sine x. While the other one, so sine squared over cosine squared is an identity. So that is sine over cosine is tangent, but it is minus tangent squared x. So multiply it with dx. But again, so we have 1 plus tangent squared x is the same as secant squared x. So therefore, tangent squared x is equal to secant squared x minus 1. And that is what we will be doing here. So we have cosine x raised to negative 2. So sine x, then minus. So multiply it with secant squared x minus 1 dx. So just we simplify it first. So cosine x raised to negative 2 sine x, then minus secant squared x plus 1 dx. So we can integrate everything. So this one is just power. So this one is integral of secant squared. So this one is power rule. But remember that our u here so will be cosine x. So therefore our du will be negative sine x dx. So we are in excess of negative. So we have a neutralizing factor of negative 1. So that's our answer there. So we have the neutralizing factor of negative 1. Then we multiplied it with cosine x. So negative 2 plus 1 is negative 1 all over negative 1. So power rule. Okay, so for the first term. And then minus the integral of secant squared is just simply tangent x. And then plus x plus c. So in short, so this would be negative 1 over negative 1 would be positive, and then cosine x raised to negative 1 is the same as 1 over cosine x minus tangent x plus c. So 1 over cosine is simply secant x minus tangent x plus c. So that will be the integral, okay, so of this particular integrand. And lastly, so we have the cosine cube all over 1 plus sine x. So we don't have the integral, or we don't have direct integral for this one, but rather so we need to transform this by using some identities. We don't have an identity for cosine cube, but what we have is cosine squared x. So therefore, I'm going to change that one into a product of cosine squared and cosine x, so which is equivalent to cosine cube. Then 1 plus sine x dx. And then we have the identity for cosine squared, so which is 1 minus sine squared x cosine x all over 1 plus sine x dx. And then 1 minus sine squared x is a difference of two squares, so I can write the product of the two. So this one is the same as 1 minus sine x and 1 plus sine x. So multiply it with cosine x all over 1 plus sine x dx. Okay, so 1 minus sine squared is the same as 1 minus sine x times 1 plus sine x. So that would be the factor. And as you can see here, so I can cancel out 1 plus sine x. And then I'm going to distribute cosine. So that will just be, so cosine x minus sine x cosine x dx. So cosine x, so we can integrate it. So for sine x, I'm just going to make u, so to be sine x. So du will be cosine x dx. So in that case, I can use the power rule. So integral of cosine x is just simply sine x. And then sine x cosine x, so that is minus. So sine x, which is u. So u squared all over 2. Okay, so again, so this one is our u. This one is our du. So therefore, it's u squared all over 2. So u is sine x, so u squared will be sine squared x all over 2 plus c. And that will be our final answer. So again, there are a lot of things to remember whenever we are solving trigo functions, okay, or integral of trigo functions. So the first thing that we need to remember there would be the 10 formula for the integral of trigo functions. Okay, so if the integrand involves the 10, okay, formula, then right away we integrate it. So if it is not, then we use some identities. But of course, we have to take note as well that we have other formula as well. So similar with the power rule. Okay, so if our u is at the numerator, so we use power rule. If our u is at the denominator, we use the natural logarithm. If a function involves exponent, the Euler function, then we use that formula. Okay, but then again, there's no exact way on what would be the right method to use. It just so happened that we just need to identify each given integrand. Okay, so through trial and error, so which is the best method to use. It is just through constant practice, so that will be able to help us. Okay, so in identifying, so which would be the best method to use in solving or finding the integral. Okay, so it is only through practice. So once you were able to solve many, okay, so many integrals or integrand, then sometimes, so once we are given or provided a certain integrand, it's just through our experience. Okay, so that would tell us so which is the best method to use in finding the integral of the function. Okay, so that will be all. Good day.